Hello again, I'm Travis Schneider with RE² Robotics, and in today's episode, we're going to talk about the software that makes up robotic systems. So joining me naturally today is RE²'s Director of Software Engineering, Andrew Davison. Andrew, thanks for joining me.
Travis, thanks for having me.
Great. So jumping in right here, Andrew, could you tell us a little bit about your background, just to get things started?
Sure. So I've been writing software for 20 years now, but way back when I was in undergrad, I actually studied theoretical physical chemistry because I thought science was really, really interesting, and how the whole world comes together and how things go together was really interesting to me. Growing up, though, I was always around computers, and so I had a Commodore 64 way back when. We wrote our own word processing program, me and my brothers, because all three of us ended up in software eventually. And so from there, I started writing software right in the .com boom, doing attendance and leave tracking systems, actually. So what most people would think of as software in the normal world of, you've got a database, you've got an application that you run in the front end of that, the user interacts with that, and you manage all of that. And so I did that for 10 years, eventually ending up making a touchscreen navigation system for a large trucking company that was installed in 2,000 trucks back in 2006, so well before your iPhone could do the same thing. And then also at Tennessee Valley Authority, where I worked to help them in the bulk power trading division. And so they would spend almost $1 billion of money a year on power from other utilities. And so I helped optimize all of that for them as well. And then I decided, you know what, it's time to move back to Pittsburgh. And so I started looking around for positions, and luckily RE² came up, and they had a need for someone with my background, which was very C# heavy at the time. And so I was hired to rewrite the ground control station for a UAV with a 16-foot wingspan.
That's awesome.
And so I worked on that for about 2.5, 3 years. And during that time, I also started learning robotics. I learned C for the first time, and C++. And my first robot project at RE² was a semi-autonomous pipe bomb removal tool. So it was a robot that could grab a pipe bomb, tilt it up, and then unscrew or cut off the cap, thus rendering it not as dangerous, because now it's a rocket, not a bomb. But the goal there was to allow bomb squads to collect evidence, because today a bomb squad would use their very expensive robot to put a pipe bomb in a ditch, and then they just blow it up, because that's the safest way to handle it. But of course, that destroys all of a large portion of your evidence, makes it a lot harder. And then ever since then, I've worked on every project that you can find on our website, from the little 1 degree of freedom robotic arm that we've sold 600 of to the 12-foot long arm that we built for Sandia National Labs.
That's great. And Andrew, one other question that I've been kind of kicking off every episode with is a pretty basic question. So we'll see how you handle this one. Who inspires you?
Well, two people come to mind. Way back in the chemistry realm, I discovered Buckminster Fuller, who was an innovator in the early and mid 1900s. He invented the geodesic dome, for instance, which is the most efficient way to create a volume. So it uses the least amount of material on the outside to create the largest volume internally. And 2 years after he had passed away, they discovered C60, which they named in honor of him, which as fullerenes. So C60 is 60 carbon molecules in a geodesic dome pattern. So he was a really big innovator, moved the world forward in a lot of different ways, maximizing um, just everything that he could see and touch. And then another person that I think is really inspiring is John Skeet. He is the #1 most reputation on Stack Overflow. So he spent a large portion of his time just helping other people answer questions, software questions on Stack Overflow, and to become the most reputation ever on that site.
So maybe just jumping right into, I guess, the meat of the whole conversation today, I wanted to steer us into a couple of questions that were a bit more software centric or a bit more software related first. So what is it specifically about software that interests you?
So in general, software has always been interesting to me because you're getting a computer to do something in a quick, repeatable, and reliable way, and it can do it way, way faster than you could ever do it. Be it calculations, be it analysis, figuring out how something could be working. But then in robotics, it's definitely making something move. So making that robotic arm for the first time actually move across a path that you requested. But it's also in robotics as well, perceiving the world, and then specifically to RE², interacting with it. So where is that thing that we need to interact with? How are we going to interact with it? And things like that are just really, really interesting to me.
That's great. So Andrew, I guess when we're interacting with customers or clients, I think oftentimes, software is kind of considered the pixie dust in between the robotic element or the more mechanical elements of a robot that make it do something meaningful. Oftentimes, I think a lot of software engineers get frustrated when it comes time to making those very specific requests and making a lot of assumptions along the way. So what are some of the things that frustrate you the most when people make certain assumptions about software? What are some of those things that really get on your nerves?
Well, I would say it's a joke that's also not a joke, and that's oh, we'll just fix it in software, because a lot of things you can fix in software, and sometimes it's the appropriate thing to do, but also sometimes it's just, oh, well, we don't have time to fix that in hardware. We'll just fix it in software instead. So that's frustrating here and there, but also part of the design process. It's a necessary thing to decide as a team how and where we're going to solve all the problems that we have to solve.
Yeah, that's a fair point. I always equate it to kind of technology whack-a-mole. So if you kind of smash down complexity in one area, it'll often rear its head somewhere else. So I heard you drop C and C#. So do you have a particular language that you have an affinity towards? Do you have a favorite programming language that you like to use?
I don't have a specific favorite. I have ones that I really, really enjoy, but then different languages are for different things. So you don't write C# or Python for a microprocessor that doesn't have an operating system, for instance. So I really enjoy the power and pure speed of C. But for productivity and doing higher level things where we don't really care how fast the software runs, Python is lots of fun. You can get a lot done in a short amount of time, but it's not going to be anywhere near as fast as C or C++.
That's interesting. I didn't know that. So what excites you about the future of software? Looking out to the future.
I'd say the most exciting area is the autonomy aspects of things. That and just the fact that in software, everything is always changing. If you become a software engineer, you are just deciding to learn for the rest of your life because everything is going to change, has changed, and will change. But at the cutting edge of software right now, I think, and our software in particular, is autonomy. So the field of AI and applying machine learning to things, and also classic computer vision to solve the problems so that the operator, when they're using our robot, literally just goes go and stop, and that's it. And the robot configures everything else out all by itself.
That's awesome. No, those have definitely been two key areas of interest, particular to RE Squared software offering. Is there's been a lot of buzz around autonomy and what we're doing in the ways of AI. So maybe now narrowing the focus of the conversation specific to robots. I guess what are some of the various pieces of software that make robots come to life? Could you maybe describe these pieces for us?
Sure. So there are lots of pieces to a robot. There are also things that in the long term we are going to have to spread out into, and that would be what people view as more normal, quote, software engineering, databases and websites for analysis and that kind of stuff. But specifically on a robot, you've got a motor that you have to control with a gear train. So you need a motor controller there with firmware that can drive and control that motor. Above that, you're going to need a higher level processor to manage all the motor controllers. And that also generally is a piece of firmware with a real-time operating system. And then back down in the motor controller, though, and also in the manipulator controller, we call it, you have to deal with all the controls problems. So when someone commands you to go to position X, you have to decide, how am I going to move the motor to get there? How hard am I going to try to get there? Do I need to watch out for interferences using impedance control or things of that nature? So there's all the motion control aspects of that, both at the individual motor control level, but then also at the entire manipulator level. And then generally when you leave one of our robotic arms, it's Ethernet and power on the way in, and that's it. So on the other end of that Ethernet cable, you're going to have another computer with higher level software. So now we're probably running in a more normal operating system, as someone might say, Windows or Linux, and writing C++ or C# or some other higher level programming language, depending on the application or the need. But the vast majority of what we do is definitely C++, in that it's very versatile, it's very fast, and it can run anywhere. And then, of course, at that higher level, now you have both the autonomy to figure out what you're doing, or what you need to perceive in order to be able to do the task you're trying to do. And then you also have the application layer state machine. So, and where am I in the world? Have I found the thing I need to interact with? Have I made the plan with what I'm going to do to interact with it? Am I now actually doing the interaction and then determining when I'm done as well? That's all high level autonomy software that we write.
That's great. And so, when developing software for a robotic system, what would you say the most challenging parts of developing that software are?
The most challenging part of robotics is definitely testing on hardware. When you first put software that you've never run on a piece of hardware that you just got, and you turn it all on, then you see a problem and you have to go, wait a minute, is that a hardware problem or is that a software problem? And so you need to narrow it down, because sometimes it is a software problem, sometimes it's a hardware problem. It kind of goes back to the we'll solve it in software, in that sometimes that's the perfect answer, is solving it in software. Sometimes that makes the software really complicated. And so being able to figure out what is the problem and where is that problem coming from is definitely, I think, the most challenging part of writing software for a robotic system. Some things we can simulate, but a lot of things you can't until you're on the real thing. Sometimes we can use a development board, sometimes we can't. So it's not unusual to write a lot of software, and then when you finally get the hardware in, now you're debugging both at the same time, and that's why it's challenging.
So maybe let's flip that question on its head and look at some of the components that are your favorite to be developing? Are there particular components that you really enjoy developing when developing software for a robotic system?
So component-wise, it's really neat to see a motor spin and controlled well in the first time, figuring that out. But then also making sure your arm moves nice and smooth across a specific trajectory. That's also an amazing component and really fun. My favorite part, though, is ironically, at least in the development process, is ironically the same as the most challenging part. It's when you're doing integration, when you're bringing a robot to life for the first time. It's by far the most challenging because you have to figure everything out on the fly. But at the same time, it's so rewarding when everything works in the end.
So, Andrew, could you tell me a little bit about two specific software components that I hear people talking a lot about recently? And those are first RE squared detect and RE squared intellect. Could you give people listening a little bit more insight into what those components are and what they do?
Sure. So RE2 detect is our internal computer vision and autonomy algorithms to figure out where we are in the world, what are the components that we view in that world. And so that includes both classical computer vision techniques, but then also machine learning and deep learning techniques in order to reliably work in an outdoor environment when it's raining, when it's night, when it's bright sunshine, when it's cloudy, covering all aspects of that, because fundamentally RE squared is an outdoor mobile manipulation company. So our detection algorithms have to work in all of those conditions. So that's what RE2 detect is. And then RE2 intellect is more the higher level state machine that I was talking about earlier, where we've got a really nice solid framework for putting together a high level state machine for autonomous systems. So you can easily adapt those four classes of things. Do I see what I need to interact with? Do I know how I'm going to interact with it? I'm interacting with it now, and I'm done interacting with it. So as long as applications are similar, then few changes need to be made to RE2 intellect. The more specialized the application, of course, the more specialized the software we end up writing.
Great. And Andrew, is there anything else that you wanted to cover today?
No, I don't believe so. All right. Thanks for asking to interview me.
Yeah, absolutely. Thanks for making some time.
Since 2001, RE Squared Robotics has remained committed to our mission to develop innovative technologies that make a positive impact on the world. RE Squared is a leader in the design, development, and manufacture of human-like robotic technology, solving the most challenging applications in the world. If you would like to be contacted about a robotics application, please email us at myrobots@resquared.com. That's myrobots@resquared.com. To stay up to date with the latest RE Squared news, visit our website at www.resquared.com, or you can always follow us on LinkedIn, Instagram, Facebook, and Twitter. If you'd like to see more videos like this, or videos featuring actual RE Squared robots, please subscribe to this channel on YouTube.